Right, I think he likes it. Whew. Let's see, I'm sweating. I literally just ran up the stairs. Just now, let me make sure you're all getting audio. Check, check, check. Right. I can make this audio. So is it sounding better now? It's better there. Audio is good. If you're seeing me type, I'm seeing you, sir. If you're hearing me type, I'm hearing you, sir. Everything is set and we're ready to go. Whoa! All right. 2025 we're here. Wow, I started these kind of sessions in 2021, 2022 for primary school, and we are 2023 was the first live series like this. And here we are, 2025. Time is flying. We are in January 2025. We are about to go. I'm seeing that, seeing and hearing you, seeing and hearing, seeing and hearing. Nice, nice, nice. So once you're seeing and hearing, press like on the find the like button, press that, and you can drop some comments. You can share with your school friends. You can share in your groups. I just ran up these stairs because I'm kind of tired and I went to make some coffee and things to try and get me through this process here. You all are going to have the best time of our life. Welcome, welcome. We're going to be doing this for a lot of Sundays in a row until exam season. But before we begin, rules. Be good. Be nice to each other in the chat. Please be helpful. You can say the answer, but don't go and type the answer 400 times in a row. You know, some of you all, every time you all come online with a different name, alias, this is not the training that you will deliver at home. You're acting differently. So don't act differently on the people internet. Please don't go and type one thing 400 times, because then I will tell you have to touch grass and you might get banned from the channel and banned from commenting and that kind of thing. So be good, be helpful, be nice, be polite, be respectful to everyone here. Just like Mr. Jesse Ashton. Jesse Ashton is saying, sir, I always good. Right, be like Jesse, be like Jesse. Number 2, I'll let you read it. 3 things. We have people from all over. So I know we have people from all over. I'm sure we have people from Trinidad, Tobago, Guyana, Jamaica, St. Lucia, Grenada. This time we have students from all over the Caribbean. I purposely targeted students from all over the Caribbean. So these sessions will be applicable. Once you are in a primary school in the Caribbean and you're about to do the exam to go into a secondary school, this is the session for you. All you want to see? Say where you're from. Say where you're from in the comments. Say where you're from in the comments. Shout out what country, what tongue you're from. We are about to begin. And the third and final thing is, wait now, only seen one star, Trinidad, Tobago, Trinidad. All right. Right now, Trinidad is running this session, boy. All right, I've seen some Guyana. Or they could tell me what they're seeing there. What other countries are they seeing? Trinidad, Guyana. All right, so the last thing before we begin, +1 868 3101 We have numbers for Jamaica, Guyana as well, but this number will work for every country, wherever you're in the Caribbean. If you're interested in any lessons in the Student Hub, or you just want to find out information about anything, you hear me say anything, we have teachers from Trinidad, Guyana, and Jamaica, and we have a large number of classes. So we have Barbados, and to see Barbados in the house as well. So when they see a new country, they could welcome them. All right, that's the 3 instructions, and we are about to take off first session for the year. So these sessions won't be in the form of a SEA style past paper, but there will be SEA style questions because we are going topic by topic. So this one is topical. The last 2 years, I did past paper samples over and over again every week, only a few topics. So now I'm focusing straight topics. And the first topic that we are going to do is Can you read that topic on the top there? That's the first topic that we are going to do. And we have to cover 65 marks today. So if you're ready to begin, type ready in the chat and let's get going. All right, so let me just go ahead and share the link with my other class here. Boom. Right, I'm seeing a bunch of readies. Let me just pick a few of you all already. Melanie, Karen, Nisha. I know that may not be your name, but that's maybe the name of the profile that you're using, Rashida. And we are about to begin, right? So what's the answer for the first one? Remember, these worksheets are designed to help you in each individual topics. I will always include some quiz questions, some multiple choice quiz questions in the beginning, and then we will go on to structured questions and then the more difficult questions at the end. Highest common factor, please do not say 64. That is the highest number there, but that is not a common factor. There's always a fight in mathematics at this level between these two. If you know the difference between these two, type I know the difference between these two in the chat. One is factor, one is multiple. Do you know the difference between a factor and a multiple? If I give you 12, can you pick out some factors? If I give you 12, can you pick out some multiples? Multiples are your timetables. We use one whole number and we multiply by this number and we will produce multiples. So if I say 12 by 1, 12, that's a multiple. 12 by 2, you see, I'm multiplying. 12 times 2, 12 multiplied by 2, 24, 36. And what would be factors? We say factors are exact divisors. By exact, we mean whole number divisors of a particular number, in this case 12. So 1, 2, 3, 4, 6, 12. These are all factors of 12 in this case. So highest common factor here cannot be a number that's bigger than any of these numbers. It has to be smaller. So therefore, highest common factor actually is 2. And I'm seeing a lot of you all have that, like Addison and Zane and the whole crew. 3 bulbs A, B, and C are connected at the same time. This is a very important question. This comes in exams. Remember, I said this is applicable right across the Caribbean. This comes in exams, NGSA, CPEA, SEA. These style of questions show up. What topic is this question testing? What topic? Who can tell me what topic this question is testing? So 3 bulbs A, B, and C are connected at the same time. If bulb A lights every 4 seconds, B every 3 seconds, and C every 6 seconds, how many seconds must elapse before they both light at the same time? Do you understand what this question is saying? I have a bulb in the corner here. It actually has 3 lights on them. Imagine if one is blinking every 4 seconds, one is blinking every 3 seconds, and one is blinking every 6 seconds. Every now and then they will blink at the same time. And the question is asking, how many seconds must elapse? That's why I need my camera to follow me back. Come on, camera. How many seconds must elapse before all the bulbs light at the same time? And this question is testing LCM, not unequal sharing. I saw some people put that. We not do not equal sharing today. I'll press like on the YouTube video. This question is testing LCM, which stands for what? Type it in the chat. So the LCM, this word is common, this word is lowest common, and of course we have multiple. Lowest common, multiple. That's the first number that all of these numbers can go into. 4 can go into 12, 3 can go into 12, and 6 can go into 12. Boom, that's the answer right there. Don't need to go any further. Some of them can't even go into 13, and anyhow you take it, all these other numbers are bigger. Number 3. A certain number less 9 is equal to the product of 5 and 8. What is the number? So we're going good so far. Are you having a good time? Easy questions, right? All your parents tell you make sure and go on YouTube and watch this Sunday, and probably use bracing for some hard stuff. The hard stuff coming in a few weeks. At the end of today's class, we have a couple hard questions. But next week we started to do fractions. The next 2 weeks, the topics would be fractions. It says the number less 9 is equal to the product of 5 and 8. What does product mean? Product means multiply. 5 times 8. And a certain number. So let's put the mystery number in this box. This mystery number, when I take away 9, that's what less 9 means, I get 5 times 8. So what I need to find right now, a certain number less 9 is equal to the product of 5 and 8. I should find what is 5 times 8. 5 times 8 is 40. So some number, when I subtract 9 from it, I get 5 times 8. That's some number. You see that? A certain number. When I subtract 9, I get. Some of you all saying 31, and some people saying 49. Make up all your mind. Who on the 49 crew? Who on the 49 crew and who on the 31 crew? Some people saying 31, some people saying 49. A certain number, when I subtract 9 from the number, I get 40. If I subtract 9 from 31, will I get 40? If I subtract 9 from 49, will I get 40? And now everyone is just jumping ship onto the 49 crew. 49 crew, those who said 49 from the beginning, we looking good. Aren't we looking good? All right, let me just make sure I have my questions up in the screen. So a certain number, subtract 9 is equal to 49. So all those who agree with 49 say me. Who got the 49 out? We're moving on to the next question. A sum of, now this term is only used in a few of the exams that I've studied. This term, less 9. But you should know what it means. It means subtract. A sum of two numbers is 3,458. If one of the numbers is 1567, what is the other number? Let's go. So I add two numbers together. Boom. I get 3458. So supposedly, one of the numbers was given to us. Not supposedly. One of the numbers was given to us. We need to find the next number. The reverse of addition is Philip, you have it there. The reverse of addition, it's time to whip out our subtracting skills. 7 from 8 is 1, 6 from 5. We're not letting that happen on our watch. So we'll bring across that 1 from the hundreds columns. We'll have 15 take away 6, which we all know it's going to be 9. And then 3 take, we have to go and get to borrow or take, might be a better word, from the thousands column. So we have 13 take away 5. So 5 and 5 make 10 and 3, 8. So 8 should go here. And then we have 1. Where do we see that? We see that in answer A. All right, 4 questions down in the first session, but I think we're going good. All you find we're going fast, just right, slow. What speed you all find we're going at? I think we're going at about just right, a little slow, but don't worry, I always go a little slow in the first session for you all to get warmed up, and then we speed up. We speed up. A carton of eggs holds 1 dozen eggs. How many cartons of eggs are needed to pack 100 eggs? So this is computation and numeration. You'll see it at the title. This means we're going to be doing a lot of operations, order of operations, numerical calculations, arithmetic, stuff like that. Well, 1 dozen means, what is this dozen word that shows up in all exams in the Caribbean? It means 12. And how many cartons of eggs are needed to pack 100? Well, we simply need to remember that our 12 timetables run like, okay, we have, I'll help me out here. We have 96. I think 96 is somewhere there, and 12 times something, and 12 times who is 96? And then we have 12 times something else, giving you 108. Am I saying this correct? Yeah. 12 times 8. 12 times 8 is 96. And then 12 times 9. So why are we saying 9 if 96 is before 100? I think I know why. Because we have all these cartons filled coming up the road. We reach 96 and we fill up 8 cartons. We have how many more eggs? We have 4 missing eggs. You all agree with me? You all see what's happening here? Understand why some of the people say 9? The 9 people are correct. Oh my gosh. The 9 people are correct because 12 times 8 is 96 eggs we filled. But what we just going to leave them 4 eggs in the dust? We're going to fry them 4 eggs. We're going to boil them 4 eggs. We need to put them in a carton too. So yes, that carton will be filled all the way. But that was what the question was asking. The question was asking how many cartons we need. So we're going to need 9. That's the least number of cartons we need, right? So well done, 9 people. I was thinking really good. Now, by the way, this style of question shows up all across the Caribbean, and it even shows up not only in primary school, but in secondary school mathematics. So they expect you to assume that assumption is expected. Write in words. All right, you all, help me write this in words. Help me write this in words. Pretend I don't know how to write this. How is Taisha so quick? Oh my gosh. Alia, big up Taisha. They say, well done, Taisha. A little Taisha from my class too. 110,205. Tell me if you all agree with Taisha. Take a snap. Well done, Tai. She agree? Let me just double check this. So she account for this 100,000, yes? 110,000. There's no number here. So 110,000, good. 205. Right? Now some places eliminate the and. So some places they say 110,205. Yeah, some places do it like that. That's totally fine if you're from a place that eliminates the and. Multiply 312 by 6. You all don't do this one. Leave this one for me. Don't worry yourself. I can handle this for you. 6 times 2 is 12. We'll put that out there. Put the 2 there. Put the 1 there. 6 ones are 6 plus 1 is 7. Wait. Did we just sneak out of the multiple choice questions all of a sudden? I didn't even realize. We out of the multiple choice land earlier. 6 2s are 12. Bring across the 1. 6 1s plus 1 7. 6 3s are 18. 1 8 7 2. And some of you all just quick with this boy. Some of you just speedy with this. What's next? Approximate 71,461 to the nearest 100. So let's take a closer look at this number. 71,461. When we are approximating, we need to find the place value that we're interested in. We're interested in the hundreds. So we can draw that line there. This is what we're interested in. Now you look next door. So I'm going to take this arrow and transfer him next door. And when you're looking at this, the whole point now is to see, is this number 5 or more? Is it 5 or more? Yes, it is. Now, if it's 5 or more, we go back to our interested place value, the place value you're interested in. And we're going to add 1 to that and change everything else to 0. So let me rewrite this now. 7, 1, 4, no. Add 1 to the 4, it becomes 5. Everything else goes to 0. And you will get the answer that everyone is getting in the live chat. If you're watching this in the future, you can click and you can view the live chat so you can feel like if you are in the live. So you can see what everyone was saying, because there's 933 people right now on this live session. Wow. So 6 squared divided by 2 is equal to 9 times some box. 6 squared divided by 2 is equal to 9 times some box. I think they want us to, I think they want us to find one in the box earlier. So find one in the box. But firstly, you need to know what is this tiny number about. Tiny number. If you see a tiny 2 above a number, if this is you, and all of a sudden a tiny 2 appears above you, what does that mean? It doesn't mean multiply you by 2. What does that 2 mean? I said the word already. What's the word? Square. Square doesn't mean multiply by 2, and I hope you don't think so. What does square mean? Square means, so if I have 5 squared, it's not the same. It's not equal to, so let me write an equal sign and cross it off. It is not the same as 5 times 2. That's wrong. 5 squared means 5 times 5. Multiply it by itself. So when you square a number, you multiply it by itself. So 6 squared is 6 times 6. And everybody should know your square times tables. Do you know your squared numbers? Up to what square do you know? Tell the chat. So we could compare and see how much we need to learn. Some of you, I would advise learning up to 15 squared and having an idea about 16 squared, 20 squared, 25 squared. Know all of these, but know all the way up to 15 squared. 15 squared is what? 225. Do you know what these others are? All right, so 6 squared is 36. Let's get back to the question. Whoa, some people know up to 20, 25 squared. So 6 squared is 36, ladies and gentlemen. Divided by 2 must be equal to 9 times some mystery number. 36 divided by 2 is 18. 9 times some mystery number is 18. All of a sudden, it becomes very apparent to us that the mystery number is 3. Just kidding, it's 2. It's 2. Therefore, the box is equal to 2. 2 times 9 is equal to 18, and 6 squared divided by 2 is also equal to 18. Insert one of the following symbols in the box below. Which one of the symbols will you use? Which one of the symbols will you use? I must congratulate you all on your behavior. I'll just answer in question brisk. I'll come out for them this new year. Maybe I'll had some nice New Year's resolutions. Parents, well done. Good job with these kids. The future of the Caribbean is in good hands. 0.76, 0.67. This is clearly bigger. When it's bigger, we always put the bigger side of the alligator's mouth to face the bigger number. So like if there's 30 here and 20 there, that's good. The alligator is always trying to eat the bigger side. So, boom. Nice rewriting. Easy stuff. That's called the more than symbol. 0.76 is more than 0.67. I'm sure we'll see that again in the future. Write the missing number in the box below to make the statement correct. 18 times 5 plus 18 times 8 is equal to, hold up, I don't need to calculate this. This is testing, asserting. Let me see if we have any super scholars here. Do you know the name of this topic? It shows up, I think it shows up in all the exams. I'm certain it shows up in 3. I'm not too sure about CPEA, but it shows up in NGSA, PEP, and SEA. What is this topic? I know you're, yes! So Celine has it, Aria has it, not BODMAS, not BODMAS. Well, it has a little bit of BODMAS, but the core topic is distributive law. That's the main topic being tested here actually. Distributive law. Do you want me to explain the distributive law? You already know about the distributive law. Because using the distributive law, we are seeing that we have a repeated number here, which means the other number we can proceed to add it. 5 and 8 is 13. Explain. A few people want me to explain the distributive law. The distributive. Do you say distributive or distributive? The distributive law, boy. Here's what it does. Here's what the distributive law about. If I put a number 4 here, some random number, or you want me to use shapes, let me use shapes. I'm sure you're good at draw triangles. If I put a triangle here, a square here, and a circle here, the distributive law says that the triangle is going to wet down the other 2 numbers. That's what you see. The triangle is going to wet down the other 2 numbers. So you get this. That is the distributive law. That means something. That is the distributive law in practice. Distributive law says a little more than that, but that is what you need to know. So triangle by square, triangle by circle. Here's what that means. If I saw 4 times 10 plus 4 times, and let's just make up another number, 11. The 4 is like the triangle in this case. The 4 is multiplying these 2 numbers. So it means I can gather this 4 like this and proceed to add the 10 and the 11. Do you see that? You see that? Triangle by square, triangle by circle. 4 by 10, 4 by 11. 4 by 10, 4 by 11. I can separate it. I can distribute it. I can expand over bracket. So the distributive law really asks the question, how does one operation interact across another operation? And if it can do this, it is said to obey the distributive law. So 4 by 10 by 4 by 11 is the same as, plus 4 by 11 is the same as 4 into, when you see this bracket, we say into 10 plus 11. So there are some nice ways that they test this, and hopefully we'll see some more in the future. So here's how they are testing it here. If you can put on your expert decoding skills, you can see that this is clearly a distributive law question because of the repeated 18. So instead of working out all of this and then having to work out this with the division, you can just add the 8 and the 5. All right, that's enough talk on that because everybody wants to divide this 1064 by 8. Do you want to do long division or short division? Please pick short division. Do you want to do long division or short division with this class? Short. Do you want me to do long division or short division? Short. Thank you, Tristan. Tristan, come to the front of this class of 1,024 people. Very good. Emery, who said long division, go into the back of... Just kidding, Emery. Just kidding. You can sit where you are, right? So you'll do some short division because who really wants to do long division in the exam? Not me. 1064 divided by 8. 8 into 10 is 1, remainder 2. Let me do the working in blue. 8 into 10, 8 goes into 10 one time. I ignored the 1 because 8 can't go into 1. So 8 into 10, 1, remainder 2. 8 will go into 26 now. So I treat this as 26. This 2 came from a higher place value. So it's like 20 to this 6. 26. 8 into 26. 8 3s are 24. 8 4s are 32. That's too big. So let's go with 3. And 26 minus 24. You all can do that in your mind. 26 minus 24 is 2. And then 8 will go into 24 3 times. I'm seeing a bunch of you all still screaming long division. You know? All you can give me 5 minutes. No, not 5 minutes. 2 minutes to just do the long division for these people who want to do the long division. Boy, some people like they sign a contract with long division. Boy, wait. 106. But everybody should know how to do long division. Eh? So when you do long division, we usually write it like this instead. So I'm still going to do a shortened form of long division here. I'm not going to show the extra steps that they show you like 2 years ago when you were in standard 1 and thing. 8 into 1, 0, 0 by 8 is 0 minus bring on it. No. We're not going to do that. So here's what we're going to do. We're going to say 8 into 1, that can't happen. So you can go ahead and put the 0 there. 8 into 10 now is 1. Because 2 8s are 16. That's too big. 1 by 8 is 8. You multiply because the long division looks like this. Rate out of 10 how much you understand long division. Do you remember this? This is the long division flag. Do you know what these letters stand for? Have you been to long division country and saw their flag? This letter stands for divide. We divided 8 into 10. We got 1. This letter stands for multiply. Multiply 1 by 8. We get 8. This letter stands for subtract. 10 minus 8 is 2. What does this letter stand for? Apparently, some people saying dirty monkeys smell bad. Well, that's what they tell you to help you remember the letters. But that last letter doesn't stand for bad. It stands for bring down. So let's proceed to bring down that 6. 8 goes into 26. We already know that's 3 times. So when we multiply 3 by 8, we get 24, and we subtract again. Divide, multiply, subtract, bring down. 2, bring down the 4. 8 goes into 24 3 times again. 3 by 8, 24. Subtract 0, 0. When we get 0 there, it means what? It means that 8 is actually a exact divisor. It's a factor of 1064. No remainder. And that's the end of that. 133 is the answer. Let's move on to the next question. Writing figures. All right. We really an easy land here, boys. Somebody must be smiling. I can do this every Sunday. And yes, sir. Go ahead. Go ahead. I thought it was going to be unequal sharing they bring in for us here, but there's some good stuff. 93,007. So let's just put and 7. Is this 9 in the thousands column? Tens of thousands. 93,000. This is in the thousands. No, something wrong. Something wrong here, Leah. Something wrong there. Like you tell me what was wrong here. So this is not 93,000. This looking like 9,307. 93,007. What should I do to fix this? Yeah, I need an X zero there. Now let's check this out now. 3,000, 93,000. This is the tens of thousands column. 93,007. This was kind of tricky, boy. You could accidentally leave out a zero there. And some people in the comments did actually leave out a zero. Don't think I didn't see earlier with the little zero left out there. Don't lose no marks on these easy questions. Don't lose no marks. Let's keep going. The number 146.45 is doubled. Doubled? What does doubles mean? I know the Trinidadians in the chat have a different understanding of the word doubles, and they probably know what I'm talking about when I say this, when I draw this diagram here one time. You don't know what I'm talking about. And doubles doesn't mean that. Double in maths mean multiply by 2. It means multiply by 2. So let's just proceed to multiply this number by 2. 2 by 5 is 10. 0 put the 1 there. 2. Hold on, let's just do it like this. 2 by 4 is 8 plus 1 is 9. Let's ignore the decimal point. Oh no, we can put it in. But we multiplying decimals, you can ignore the decimal point and put it back in the end. And sometimes that is the safe thing to do when you have two decimals. So 2 by 6 is 12. The 2 goes here. The 1 goes there. 2 by 4 is 8 plus 1, 9. And then 2 by 1 is 2. So now when we put back the decimal point 2 places, 1, 2, we end up with this beautiful looking number, 292, very symmetrical, and then boom, a 9 coming here. I mean, it killed the symmetry, but it still have a kind of repeating vibe state. Nice number, nice number. 292.9. Let's keep going. Write a whole number in the box below to make the statement true. All you know, I'll just mess up this question in exams. Ask any maths teacher. Show a maths teacher watching this like, yes, sir. Talk to them. Talk to them. But good student getting this wrong. Come on. This is one of those questions you're allowed to put so many different numbers. And still some people get it wrong. All right, let me make sure I don't get it wrong because that ain't gonna look good. So I need to get something that is less than 5026 to go across on this side. Less than 5026. This is more than 5026. So which means I should try and take away a lot from it. So to be safe, I could even take away the whole thing. That's a good number to put in there, right? Just make sure you didn't take away too little bit. So like if you put a number like 45 here, when you take away 45 from this, all of a sudden you get 6,300. And that's not enough to be less than that. So some of you all will want to subtract this from this and measure it and make sure it's exact and thing. I, on the other hand, prefer to be on the safe side of the law. So I will just make sure I put a nice number that clears my situation here. 6,000 looking good. 6,345 minus 6,000 and it's gone. It's gone. It's 345, which is less than 5026. Don't overthink it and get too fancy and lost the mark. Circle the number that is not a prime number. Which one of these is not a prime number? We are on number 16. Just now I will tell you how much questions we have. Hold on. I need to go back up. See, a lot of you all were saying a certain number there. So a lot of you all calculated it and got the number 1319. You all saw that number in the chat? Type yes if you saw that number in the chat. A lot of you all were saying that number. You subtracted and you got that. If you put that number there, it will be wrong. If you put that number there, it's wrong, eh? Because if you subtract this from this, I think you are going to get, just check the first one. Yeah, you're gonna get this number. So don't put this number in here because 5026 is not less than 5026. They are actually equal. You see what I say? some of you all overthinking this question and getting it wrong, and you all are so smart and you're getting this question wrong because you're overthinking it. You need to put a number that's bigger than this. So if you put 1320, that's good. That will work. It needs to be bigger to go smaller. All right. I talk enough on that. Don't let me down. Circle the number that is not a prime number. A lot of you all are saying 91. 19 is prime. Welcome to the party by 19. Can you give me the definition of a prime number? Definition of a prime number. There's like 2 definitions you can use. And I'm hoping that some of you all are hastily typing right now. Has 2 factors. That's wrong. It's kind of correct, but it's wrong. A number with only 2 factors would work better. A number that can go into itself. Why do people keep saying this? You all keep giving me the definitions halfway. A prime number. Let me go and select one out that is really good. This could work, Jenny. Oh, I missed. Again, Dominic instead. The comments coming so fast. A number that has 2 factors, one and itself. That has 2 only factors. I would like, Dominic, if you take that only word and just bring it in front of 2. Please. Prime numbers are numbers that are divisible by 1 and the number itself. In other words, prime numbers are positive integers greater than 1 with exactly 2 factors. I love this. This man like he ripped this off at Google. If you knew that all of that, use ChatGPT. So a number that is only divided by 1 and itself. A number that has no factors except 1 and itself. Yes, so you need to be exclusive. Prime numbers belong to an exclusive club. 1 and itself are the only. So can you tell me what is the first prime number? Let me ask it in a different way. Is 0 a prime number? Yes or no? Is 0 a prime number? Yes or no? So some people say no. I just now see flash across the screen somebody asks for a break. No way! No way you asking for a break and we need 37 minutes in. You have to raise your math stamina. You need to get a maths bike and start riding it. Because you need to raise your math stamina. You need some more. Nah. We now warming up. So anyhow, 0 is not a prime number. So don't get tired. Not a prime. Not a prime number. Is 1 a member of the exclusive prime number club? Can 1 enter the prime number party? Is 1 invited into the prime number dance? 1 is also not a prime number. So 1 is given a little exclusive club to be in by himself. 1 is called the multiplicative identity. It only has 1 factor, 1 and itself, which is 1. So it's not filling that definition of prime. We don't include 1 into the prime number dance. In fact, the first prime number is actually 2. Yay! So 2 is the first prime number, and it's actually an even number. And it's actually the only even prime number. That's a lot of information right there that could show up in your multiple choice. Those of y'all who get multiple choice in your exams, not SEA students. So 19 is prime, 73 is actually prime, but if you didn't know, we know 13 is prime. You should know all your prime numbers up to somewhere in the 30s. You should be able to identify them. But you should know you never saw 73 on a times table. Let me give you a little tip, parents, students, teachers even. 91 is a very popular number in exams with this type of question. Very popular. 91, 93, 99, 95. Very popular numbers. 91. Shows up even in CXC. Please know that 91 is not a prime number. 7 can go into 91. And 13 can go into 91. 7 times 13 is 91. So just remember that and you're good. Right? Plenty of exams. I'm pretty sure sometime in your secondary school life, you will have to know that 7 and 13 could go into 91. You might as well learn it today. All right, let's keep going. Write down the value of the underlying. So that is the one I will circle, right? It's not prime. Write down the value of the underlying digit in the place value chart below. Where is it? Where is it? Where is it? Where is it? Bang, there it is. Do you see it? It's underlined. It's kind of tiny, but it's there. So write down the value of the underlying digit. Now, this is something that's tested in every exam right across the Caribbean. And they always use these two words. And every year, students get mixed up. So sometimes they say value, and sometimes they say place value. Nod your head like this, right where you are if you know the old trick. Do you know the tricks? Sometimes they say write down the value, and sometimes they say write down the place value. We'll come back to that later. So the answer for this, when they say value, it's 5, and all the rest will turn to zeros. 0, 0, 0, 0. 50,000. 50,000. Do I have a little space to write it in here? Let me write it in the space there, man. All right, so add 2.49 and 5.65. No problem. No problem. 9 and 5 is 14. 4 goes there, 1 goes there. 6 and 4 is 10. Plus 1 is 11. And we have 8. And this was the decimal point coming there. 8.14. Aha! This is the first question since the starter managed to kind of do it before the chat do it. I race a lady. That's the first one I win earlier. 8.14. So we got to go. Write an expanded notation. All right. So all you want to know the secret with these two, value versus place value. If they ask for place value, you can't write 50,000. You have to write tens of thousands. If they ask for value, you have to write the 5 with the 1,000, with the tens of thousands. So you have to write 50,000. Understand? Some of you all know it already, right? If they ask for place value, you can't put the 5. You just need to put tens of thousands. That's the place value. If that's the actual value, you have to write only 50,000. Right? 25701 for an expanded notation. So that's 2 times, 100,000. How many of you all know how to expand up your notations? That's 5 times the 10,000. This is the tiny line. All you give me to do this? This is 7 times the thousands. Next time, do better. Yeah? What a big space. This is the 0 times the hundreds. Can be left out, but let's just put it in for fun. 1 times the tens and 4 times the ones. That is your expanded notation. So the expanded notation, we have products separated by the addition operation. The product is the individual number, as you can see, multiplied by their place values. So 2 times 100,000, and you go on like that. Somebody in the chat said, sir, make your own line. I like you, boy. That's a good idea. Ha! Sometimes in life, you don't have a line for what you want to do, and you need to make your own line. Write that down. Write that down. Write that down. So 29.4 divided by 7. So a nice little division here. We're going good. We're going good. When we reach number 25, remind me to show you all how many more questions we have to go, right? When we reach number 25, we'll have a tiny break where I will be looking at how much more questions to go. So 7 into 29. 7 into 29 is 4. 4 sevens are 28. So there's a remainder 1, and 7 into 14. Well, the decimal point is lined up here with the short division. 7 into 14 is 2. 4.2 is looking really nice. Real nice. And then 21, arrange in ascending order. I have been known to mix up this when I'm talking a lot. So let me take my time and make sure I get this properly. Going up, right? That's not my camera. Start following me again. All right, good. Ascending means going up the hill. So we're going up the hill. And if we're going up the hill with our walking stick there, if we are going up the hill, we need to start with the smallest number because we are ascending up the hill, going up. We need to start with the smallest number and reach to the largest number, right? So from small to big. So who's the smallest guy here? But you looking like the smallest. 2078. You have a 0 there. All these others have something, and you at the 0 have 8. So you will come in next. Am I going good? So far, so good earlier. And then what next? This is a 7. This is a 8. So it gets kind of easy. You just want to make sure you make no mistakes, because Why lose easy marks? Yeah, 2078, 2087, 2708, and 2807. They try to trip you up with all the 7 and the 8s and thing, but we're ready for them. Calculate 2.2. All right, let's ignore the decimal signs. How about that? We ignore the decimal point. Ignore the decimal point. Just work with it as is, and we'll bring back the decimal point when we finish do we thing. So we have 2, 9, 8, and 7. Are you feeling okay with that, or that's scaring you all? I hope you're not getting frightened with that, right? Because that decimal point, God, it's a little annoying right now. So let me just ignore that right now. But let's track how much we move it by. 1, 2, 1, 2. Cool? 4. 7 8s are 56. That's one of the hardest tables to remember. 7 8s, 56. So make sure you remember that. 7 by 9 is 63. Plus 5 is 68. So let's go at 8 there and bring this 6 across there. 7 2s are 14. Plus 6 is 20. All right. Now is the moment of truth. Now is the moment of truth. Truth. And you have, hey, hi, miss. See, Miss from Guinea, Miss Samantha. What's up? So when we move this across, we need to count how many times we move it this way. And then kind of send it back that way. Well, we move it 2 times. 1, 2. No. You need to add both. You need to do both of them. So it's really 4 altogether. So 1, 2, 3, 4. Lo and behold, this decimal point came in front of our 2. So what we usually do is we add a nice little cute 0 here. Doesn't change the value of the number. It's more like a stylistic 0. It's more like for style, so that you can easily identify where the decimal point is, right? And see that it's a decimal number. 0.208. All of you all got that out? Well, there's bosses at this point. Write the digits in the squares below to create an addition problem with the smallest sum. Do you know the trick to do a question like this? Do you know the way to solve a question like this? We nearly reached number 25. I want to reach number 25. I'm going to reveal to you all how many more questions we have to do. Do you know the trick? If you want to get the smallest sum, it's important that you try to get the smallest numbers in the high place values. See what I mean? So you're trying to make the smallest numbers to add up to make the smallest sums. So if I put 42, that's bad. This 2 is smaller, so I should put really 24. And hold on. I can do it even smaller. Why should I put this 4 here and this 6 there? This 4 is smaller than the 6. So 6, you go here now, bro. And let the 4 go. You all understand what I'm saying? I want the smallest numbers in the higher place values. That's the trick. So not some of you all have 24 and 68. I think I get in a smaller number this way. 26 and 48. And do you understand why? I'm taking these bigger numbers, these larger numbers, and saying, since I want to be big, go in the ones place value. And we'll put the smaller numbers in the larger place value. And that way we'll get something that's small. 6 and 8 is 14. Bring across the 1 and we get 74. So I think the question really just wanted us to write in the digits. So we're good to go from there already. Computation and numeration is the worksheet that we are doing today. It's going to help everyone at a standard 4, 5, 6 level with their mathematics. On Saturday, Mark solved 30 math problems. He solved 4 times as many problems on Sunday as he did on Saturday. How many more problems did Mark solve on Sunday than on Saturday? 1 mark. The thing that is annoying about this question is 1 mark. The next thing that is annoying about this question is I read it and I didn't even understand what I read. So I had to read it again. Oh my gosh. So Saturday, maybe I'll write Saturday and put 30. That's how much math problems he solved. Then he solved 4 times as many problems on Sunday as he did as see how writing it help out? See how writing it help? No. So on Sunday, you do 4 times. I want 2 marks to this question. Don't give me no 1 mark. So 4 times 30. How many more problems in marks have on Saturday? 4 times 30 is 120. I feel like I do 2 steps here. 120 minus 30 is 90. The difference between Sunday, which is 120, and Saturday, which is 30, I just double checking, is 90. I hope you all could be like Mark and solve what. Anybody ever do 120 maths questions in a day? Like Mark have exams in the morning. Arrange these numbers in descending order. So we're going down now. We're going down the mountain. So we in a cart going down the mountain now. No, that's our legs in the sky there. We're going down the mountain, right? So we start off with big numbers and we go to small numbers. Big, boom. 7510, that's the biggest number I'm seeing there. 7150, 7051, 7015. All right, we reached number 25. You know what that means? Nah, the first session. I'll change my mind. No break. Just kidding. We're gonna have like 2 seconds break. I want to scroll down and show you all how many questions we have to do. Ooh, we're gonna do some 2-mark questions. They're gonna get tough. We reach number 25. We have to go all the way up to number 46 on this worksheet. 46 questions we're doing. Not as many questions as Mark. Mark did 120 questions. So 46 questions. All right, Talia. It's time to break down there now. All right. Count to 20 and then we'll end the break. Count to 20 and then we'll end the break. Count to 20 and we look to end the break. I'm just checking out my different layouts that I have here now. Oh, I can actually take myself out of the screen too. Are you finished the count to 20? Press like on the video and share it in one of your groups. Maybe you have a friend group. Press like on it and share it and tell them, hey, let me come and learn some maths now. Do something with your Sunday. So I'm teaching a class. Yeah, my son, like he hear it was on a break and he come to see what's going on. All right, so ting. Oliver more? Nah, break done. Hashtag break done. Hashtag break done. Some of you know who that is already, and you don't know which one of my son is that already. Hashtag break done. Yes, I am, boy. Oh gosh. So what number? Oh, we reached nice questions, Alien. Nice. If you know I love these questions, what number must be placed in the box to give the result shown? So we want to know what's the starting number. So it's like a little machine. The number came in here and then bang, add 10 to the number. You get something and multiply by 3. 105 pop out. So to solve these questions, you need to turn the machine backwards and go in reverse. Bang, to come back to the first number. So if you turn this function machine, this operation machine backwards, what happens? Well, instead of multiplying by 3, you do the reverse of multiplication. In maths, we call it also the inverse. Instead of reverse, we use this word sometimes. Inverse of multiplication. So if you were multiplying, walking forward, when you are going backwards, you are going to divide by 3. Let's write that so we don't make any mistakes. Then the reverse of adding 10, the reverse of addition is subtract 10. Yes. All you need to press like on the stream, because where else you will go and get these amazing sound effects. So we divide by 3 and then we minus 10. All right, I'm ready for them now. 105 divided by 3, that's easy. 3 into 10 is 3, remainder 1, 3 into 35. 35 times 3, 13, 90, 15, and yes, that works. 35. And now I'm going to subtract 10 from 35. So I went this way. I had 105 and it passed here and it turned to 35. 35 minus 10. 35 minus 10 now is, of course, 25. A lot of y'all were shouting that number from the word go. Y'all are really good at this. So 25 is the number that I want to put there. It's 25. Very good. 27, right? The next term in the sequence. So what's happening with this sequence? The first thing that I always check in a sequence is to see if it's a constant addition. 1 and 12, to get to 12 from 1 is you're going to have to add 11. Right? 12 minus 1. 11 and ha. Have we just like literally solved this question there? 34 and 11. You see why that's the first thing I always like to check? Because a lot of times it's something simple like that. 5, 4, 45, bang. We just scroll on by. We starting to cook now, right? I think we're starting to cook. Hashtag cooking. I think we're starting to cook. 5.76 subtracted from 9.20. Yeah, I think we warming up now. We fully warmed up. Like that break coming handy. 6 from the 0, that's not happening. So let's have 10 minus 6 and we get 4. 1 from the 7, it's annoying because that 1 is smaller than the 7. So we're going to have to go to this other place value. And we have 11 minus 7 is 4 as well. And then 8 minus 5 is 3. Let's just double check this. 3.44, 4, 80, 40, 20, 3, 5, plus 1. Yeah. Feeling reasonable. Feeling reasonable. Remember, we're cooking now. We can't afford to make any mistakes. A pizza restaurant baked 184 pizzas and they need to distribute them equally among 8 delivery drivers. How many pizzas will be delivered? Will each delivery driver receive? Hold on. So we have our little pizza restaurant here. Bang. What's the name of a nice pizza shop, boy? And then we made 184 of these pizzas. And we need to... Oh, we have a bunch of delivery drivers. We have actually 8 of them. At distribution. At division. It's division. So we just need to see how many we'll get. I hope it's exact, because anything else will kind of be a little scary. 18 to 18 is 2, remainder 2. That's 16. 16 from 18 is 2. Right? So 23. So it was just a division all along. 23 times 8 is 184. And we'll be able to dice it up. How many questions did we find out? For those who missed how many questions we're going to do, how many questions are there in this worksheet? Every 6 customer entering the amusement park was given a discount. Imagine if this was true. Any one of you all have been to amusement park before? So you had to wait until you see 6 people or 5 people going and then running and be the 6th one. 129 persons enter the amusement park. How many more persons must enter for next discount to be given? I see where you're going with this. I understand. I understand it now. So, okay. So 1, 2, 3, 4, 5, 6 persons get a discount. 7, 8, 9, 10, 11, 12 persons get a discount. So all I need to do now is keep writing all the way up to 129 and I will know what's going on. Of course, I can't do that. They're smart. They choose a big number because they didn't want me to use this technique. However, because I know maths, I know that 120 is divisible by 6. 6 could go into 120 20 times. So I can start from 120. That's one of the ways I can do it. And I can say 121, 122, 123, 124, and go all the way up to 126, which is also divisible by 6. So you also get a discount. And then we have, careful with this, and I get a little confused there, 127, 128, 129. So you don't get a discount. I have to go 130 sounds really, really promising, but it's not divisible by 6. 131, 132, we're on 129, 133 is 133 or 132. Which one of these is divisible by 6? What's the next number that will be divisible by 6? After 129, what is the next number that's divisible by 6? 132, right? We can double check it. 6 into 132 is 2, remainder 1, 2. 22. 22 times 6 is 132. So therefore, how many more people? 1, 2, 3. Those of y'all who are screaming 3 from the word go, you are so smart. It's 3 more persons until we get to that 6 discount. Very nice. Let's keep going. Write the missing terms in the sequence below. Congratulations on making it to question 31. Do so and give yourself a handshake. Not everyone will be able to last all the way until question 40 something. Write the missing term in the sequence below. What in the world is this little house? Why are they putting the numbers under a house? Who can tell me what this house means? When you see this house in mathematics, when you see this little shed in mathematics and a number is like finds himself under this shed, what does this mean for the number? If you are a number and you are under that shed, it means square root. Square root is the opposite of the tiny little symbol we are seeing just now. Remember, we had a tiny symbol like 2, and I told you that means multiply the number by itself. 3 squared equals 3 times 3, which is 9. Or, I think we had 6 squared, and that was 6 times 6, which is 36. Well, here what? If you want to go backwards, you got to use that little house. If you want to do it, that function backwards, here's how it works. So we can say, so for example, 6 squared means 6 times 6, which is 36. If I say the square root of 36, that is going back to 6. So I need to know what is the square root of 121 and the square root of 10 and the square root of, hey, something is missing. Oh, I love this question. We reach into the big boys question now. These are the big boys questions. Do you know what number multiplies by itself to get to 121? I want to tell you in the big boys question now. 11 times 11 is 121. Do you know what number multiplies by itself to get to 100? 10 times 10. Do you see what's happening? Can you guess what I need to put here? 9 times 9 is... So up here, imagine here, right? I need to have the square root of 81 plus... So, hey, there was something else to add on here. So I need to examine this part now. What's going on here? Well, this is 4, 8, 16. It's going up by 4. 4, 8, 12. You all for 12? I'm for 12. Then, let's see this. This is the square root of 64, which is 8 times 8. I love this question. So do you know what's going to happen here now? We have to get the square root of what number multiplies. 7 times 7 gives me what number? 7 times 7 gives me 49. And I'm 16 plus 4 is 20. How many of you were able to get that out without my help? If you were able to get that out without my help, well done. Press like. Press like. let's tell me how much likes it have on the YouTube video. Tell me how much likes we have, because I can't see it on this screen that I'm on. So I hope it have good likes there. I hope it have a good number. There is 1,100 people. 100 people here. Sometimes when I say press like, I just say and forget to press like. Just press it now, you know. Let the stream go. So this seats in an auditorium, 580 likes. I'll at least make it reach 700. At least make it reach 700 likes. The seats in an auditorium are numbered in sequence from 1 to 224. There are 8 seats in a row. How many rows are there in the auditorium? So these are kind of patterns question. They hit it. You know, this is that they hit with the patterns now. Seats in an auditorium are numbered in a sequence from 1 to 224. There are 8 seats in a row. All right. So 8 seats in a row. So you understand? Every row have 8 seats, like 1, 2, 3, 4, 5, 6, 7, 8. And how many rows? I think we need to divide. Because if you have 8 rows, 8 seats in a row, and I need to find out how many rows, and we have 224 seats in all, I'm going to hit them a division and hope for the best. I am going to hit them a division, ladies and gentlemen, and hope for the best. I feel like I divided by 8 real plenty in this paper. I don't want to see no more divide by 8 in this paper. 8 into 20, 8 into 22 is 2 times remainder 6. 2 6s, 2 8s are 16. 22 minus 16 is 6. Yeah, boy. And 8 into 64 is 8 times, so 28 rows. 28 rows of exactly 8 seats. We're so smart. Sometimes it's hard to big up your own self. You know? In which row can seat number 85 be found? Don't worry, I know how to do this too. I have a new plan for this one now. Just now, it coming to me. Well, 1 to 8 will be row 1. Then 9 to 16 will be row 2. Of course, I could keep going, but I feel I have a next way to do it. You understand? 2 times 8 is 16. So if I could find out one number is the closest multiple of 8 here, I could probably figure it out. You understand? This row, something to 80. 8 times what? 8 times 10. That's row 10. So if it's 85, it passed the row 10. I didn't reach 88 yet, which is the last seat in row 11. So I know that this is somewhere here. 85 is somewhere in row 11. And a lot of you all got that out. Some people will say in row 10, which is a nice, that's an understandable mistake to make. It's still a mistake. They will still say no marks for you. But understand why we choose row 11 and not row 10. Although you get yes 80 and 88 is more, it is in the row with that seat 88. It is in the 11th row. The first row goes 1 to 8, the second row goes 9 to 16. This is the reason I kind of map it out here to show you what's happening. So it's not a row 10. Row 10 is actually what? 72 to seat 72. Sorry, seat 73 to seat 80. Stay woke, people. Stay woke. Know how to count your auditorium seats. Don't let them trick you out here. Fiona bakes pastries. Just now, let me show you a comment I just spot. Let me just show you a comment. Zion. Yes, head by mommy, please. I just spotted this comment from Salita. Salita said, we need a better break. Salita, I'm a man of the people. If the people really want a break, I just give break and thing. But I'm feeling like we could go with. This is the first session, Salita. This is the first session. Next week we could probably work on improving we break dynamics. But let me see if we could go through with no break now. Let me girl party done. No break, so we nearly done. You see? That's the way I want. Salita, pick up yourself. And let me go. Fiona bakes pastries over 6 days. The number of pastries made follows a pattern as shown in the table below. Number of pastries read on day 1 and day 2 are not shown. Oh my gosh, they left out day 1 and day 2. Is she making it in some kind of pattern? Yes, boys, a pattern by Fiona. Boy. Salita, pattern. how many pastries are made altogether for these 6 days? Hold up. Before we add up everything, we need to figure out this pattern. What is the first thing you always check for when you're looking at these patterns in these exams in the Caribbean, boy? What's the first thing to always check out? They love to see like a common difference. It's literally called a common difference. When you reach in secondary school, you'll see 4 and 3, 7. This adds 7, 47 minus 1 is 6. You all could check it out and see if that makes it. Oh no, it's not common. It's not common. So it's not like you're adding 7 all the time. Hold up. I feel like I know what's going to happen here. Are you smelling that? I'm smelling what's going to happen here. 41 minus 36 is actually 5. You all can do these subtractions mentally. You need to write it down. So hopefully you can do it mentally and you're starting to see that it's 1 less all the time. So, all right, Miss Fiona, who likes to bake pastries, I am going to put those numbers there because I know I should do 36 minus 4 and get what? 32. How many of you all feeling like that? And then 29. 32 minus 3, right? 29. We cook it. We cook it. And then we need to add it all together. That's a lot of numbers to add, but don't worry. We are very good at this. We are very good at this. We do not make mistakes when we are doing this. Here's what I like to do when I do this, right? I always like to look for patterns to see if I see 2 numbers that add together to make 10. I'm seeing 2. I'm seeing you and you will make 10. How many of y'all do that? This and this will also make 10. So I already know that's 29. This is going to add up 2. How many of y'all do that? We cooking out here, boy. Or baking as the case may be. Fiona is baking, but we are cooking. 9 and 1 is 10, and 6 and 4 is 10. I know all the other numbers that add to make 10. 7 and 3 make 10. 9 and 1 make 10. 8 and 2 make 10. 5 and 5 make 10. 6 and 4 make 10. If I see these numbers anywhere on the street is on site, I know that they will add together to make 10, and that really helps me out sometimes. So, and then I have 2 and 7, which I also know makes 9. So this is 29. And then I put the 9 there, put the 2 here, and let's look for any other patterns that we're going to see. 3 and 3 is 6 and 4 is 10. See that 10 pop out again? 4 and 4 is 8. No 10. Well, what I would have done is say 4 and 5 is 9. So I'm 19. 19 and 9, adding numbers to this 9 is easy. Because if I'm seeing 4 and 19, I know that's 1 less than the 4. It's going to be 23. So I hope that is what you did. And you were able to get 239 pastries. 239 pastries. How are you feeling about that? What kind of desk that I stand up here, but I needed to come up a little higher. I might show you sometime, right? Probably this will go up and down, I think. Write the missing digits. 10 more questions to go, about 10 more. Write the missing digits in each box below. A. So, sometime, I think it's 2 years ago, I was doing a question like this. And I started the question hot and sweaty. And I put 7 here and 3 and then I realized, oh, shucks. The question is subtraction. So the first thing you should always do is watch what is really happening here. Sometimes they bring addition and sometimes they bring subtraction. So we 2, 5, 3 minus 3. So I know 1 came here at least. 13 minus 3 is 9. So I know something was borrowed here. And there's another way to do this question. There's another way to do this question. So I can do some kind of trial and error stuff. That was the next thing I did at time. But there's a faster way to do this question. Let me show you. So since I know 5 cannot be subtracted from 2 in this situation, I will, boom, take 1 from you, bring it here. 12 minus 5 is that 2 plus 5 is 7. How many of you all got that first number out? No problem. So once you get this first number out, the fastest thing to do in a situation like this is realize, well, if I subtract from this big number, and I got this, the fastest thing to do is just add up these last 2 numbers. There's another thing you can do, but I think this might be faster if you're really good in addition. And who doesn't love to add? So I can just add up these numbers and get back my boy on top there. 7 and 5 is 12. Bring across the 1. Yeah, so we get 13. Bring across the 1. 6 and 8 is 14. Bang! I just figured it out. I just figured it out. It's a big, nice 4 that's going to come there. You see that? This came in SEA. I see some stuff similar to this in NGSA. It's a popular question. It's a popular question right across the box. Did I make a mistake? Let me just make sure. Next thing I didn't make a mistake here. Where do I add? I'm adding 7 and 5, 12, bring across the 1, 13, 4, 13, 6 and 8, 4. Oh, yeah, good. Yeah, boom, 4. I love it. So watch out for this. I give you a nice technique there. There's another way you can do it here, but you know what? Let me just go to the next question. A jar contains chocolate and candies. For every 3 chocolates placed in the jar, 6 candies are included. If there are a total of 63 items, how many of them are candies? So this starts to go into a little bit of sharing stuff. A little bit of sharing stuff is involved here. This is a style of unequal sharing that we call grouping. So it shows up in the unequal sharing style of the paper, and it can show up right across the Caribbean. You can see some questions pop like this. A jar contains chocolate and candies. For every 3 chocolates placed in the jar, 6 candies are included. How many of them are candies? So what's the way to do this? Well, you need to find one group. One group will have 3 chocolates and 6 candies. Y'all okay with that? One group will have 3 chocolates and 6 candies. That means 9 sweets altogether. And we have 63 items. So 9 into, let's find the number of groups. Do you understand the technique that's happening here, people? Can you repeat this? Number of groups. So one of the things that I focus on a lot in my class, my lessons class, is getting students to formulate their own statements, because it just makes them really good in mathematics. So 63, 9 goes into 63 7 times. So we have 7 groups. Now that I know we have 7 groups, and every group contains how many, what do I want? Candies. Every group contains how many candies? 6 candies. 6 candies in every group. 6 candies, 3 chocolates. I'm not interested in chocolate. I'm interested in the candies. There are 7 groups of 3 plus 6. But every group has 6 candies. So the number of candies is going to be equal to, anybody here name is Candice or Candy? Well, Candy, let's see how many of you we have. 7 times 6, which is 42. Let's keep going. Write the correct number in each shape below to compute the number sentences. So I am predicting that these are independent of each other. No. No, 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 no. They are dependent on each other. What is this topic called? I think we did it already. What is this topic? What is this topic called? Is it really some kind of distribution, something happening here? A little bit of distribution ideas popping out here. This is kind of banking on you understanding that multiplication is repeated addition. Okay. So if I say 299 times 50, it's like if I have 50 added up to itself 299 times. Multiplication is repeated addition. So let me show you what this question is doing. If I added on, you all understand what I said there? 50, and I keep adding 50, 299 times, that is the same as if I multiplied 50 times 299. But somehow this question is saying I did that, I multiplied by 50, and then I'm taking away 50. To me, that could only mean that I did it one extra time. 299 and 1 extra 50. So 299 by 50, that's there. And then I need 1 more 50s to take away the 50. I hope that makes sense. I hope that makes sense. So let me say it again, a little slower. 299 times 50. And I'm seeing the distribution of 50 by 299. It's there. But there seems to be something extra here. And from this, I can deduce that the extra thing is an extra 50. That's why I'm subtracting it. So there's a 1 more 50. 299 plus 1 is 300. So this is, hey, why is this doing that? So this is how this question works, ladies and gents. This number is 300. The number that goes in there is 1. All right, maybe the numbers are too big. Some people are not understanding. Maybe the numbers are too big. Let's say I have 5 times 6. 5 times 6 is the same as, I don't want to use 5 times 6 anymore. I don't want to do 5 times 6 anymore. 5 times 4. 5 times 4 is the same as what earlier? 20, right? We know that, but I'm not concerned about the 20. 5 times 4 is the same as 6 times 4. Is 5 times 4 the same as 6 times 4, class? No, of course not. 5 times 4 is not the same as 6 times 4. 5 times 4 is 20. 6 times 4 is 24. This has an extra 4. So let's take out the extra 4. Is 5 times 4 the same as 6 times 4 minus 4? Is it correct now? Yes? That's what the question is doing. And then I can rewrite this as 5 times 4 is the same as 6 times 4. Well, let's go back to 5 times 4 plus 1. 5 and 1 makes 6. Don't forget to subtract the 4. That is what this question is doing. So 29 times 50 is the same as 300 times 50, but as 1 extra, so I subtract the 50. So 5 times 4 is the same as 5 plus 1 times 4. Since there's 1 extra 4, subtract it out. That's what it's doing. So it's a little bit of distribution, a little bit of understanding multiplication thoroughly. Let's go on. Derek collects, we make it to 700 likes. Yes. Derek collects 1 coin each week. The current number of coins in his collection is a factor of 60. Factor of 60 means exact divisors. So like 2, 6, 10, 30, 15. 60 is a number with a lot of factors, boy. They really hit me for 6 here, boy. They should have never choose 60. Now we had a real thing. 2 weeks ago, the number of coins in his collection was a multiple of 9. How many coins does Derek have? This is the toughest question we do so far. This is a big brain question. So we need some of the bulbs in the class to figure out how to do this question. Are you one of these special few in the class that can figure out how to do this question? Come true. Mash up this question for you. How do you do this question? All right. Let's break it down piece by piece. Piece by piece. Every week he collecting a coin, right? 2 weeks ago, the number of coins in his collection. So let's work out what happened in 2 weeks ago. I think the secret to this question lies there. 2 weeks ago, the number of coins in his collection was a multiple of 9. We need to go check all these multiples of 9s. Multiples of 9s would be like 9, 18, 27, 36. You can multiply by 9 really good because, multiplying by 9. All you know the 9 times table have a little trick with it, right? Everybody know about that trick? So 9, 18, 27, 36, 45, 54. Good. Lovely. So 2 weeks ago, it was one of these numbers. Now, 2 weeks down the road, it is a factor of 60. So if I go, this was 2 weeks ago. If I go now, I need to add 2 to this because he collected 2 more coins. And I need to find out which one of these will be a factor of 60. Is that good, class? 2 on this is 11. 2 on this is 20. 2 on this is 29. 2 on this is 38. 2 on this is 40. These numbers too big. 2 on this is 56. 20. 20 is the answer. Because 20 could go into 63 times. 20 is a factor of 60. Woo! This was a nice question, boy. So now he has 20 coins. 2 weeks ago, he had 18 coins, which is a multiple of 9. So I listed all my multiples of 9. I added 2 to them, and I saw which one of them would be a factor of 60. Not too bad. Not too bad. He has 20 coins now. 38. Ria and Kelly estimated the answer to the following problem. 80 times 27 is 1600, says Ria. 80 times 27 is 2400, or 2400, says Kelly. Explain who had the better estimate and how it was calculated. Now, these questions, just now somebody's messaging me here. Just now. Yeah, so these questions show up in exams now. And this is a weird question because this question is all about being able to, this is like the sneaking English, ELA, creative writing coming in the maths now. Explain, do they want us to write an essay? Do I have to give them paragraphs? Not really. Explain who had the better estimate and how it is calculated. Well, when we do estimates, which is a topic in most syllabus, all syllabus, when we do estimates, we estimate it, we use techniques like approximation, approximating that place value. If I was Ria or Kelly, and I can't be because I am Kerwin, I would approximate to nearest 10 here and I'll get 30. And so you see 8 3s are 24. I like in Kelly's answer. Kelly's answer. So what this Ria person do, boy, I think Ria made the mistake and approximate downwards. Come on, Ria, you're supposed to know if this is a 7, you had to add 1. So she get 8 times 2 is 1600. You all realize what Ria do? So I need to find a way to write that in words. How would you write that in words, boy? How would you write that in words? I would say something like, firstly, I want the mark. So the first thing I'm going to say is, Kelly had the better estimate. Let's see if I can get another color here, but is that a possibility? Had the better estimate. Kelly had the better estimate. She rounded 27 to 30 to get 80 times 30 equal 240. Ria's estimate append to round 27 downwards to 20, which is not a correct approximation to the nearest 10. All right, Daniel. Yeah, you can do the working, like what I just did. So, somebody wants something harder. Don't worry, we come into the hard topics just now. We're coming into fractions. Next week we have some tough stuff. Joseph is keeping track of, those of you all in the class, I'm going to send you all the solutions so you all could watch it over. Joseph is keeping track of the number of push-ups he does each day for a week. The number of push-ups follows the pattern as shown in the table below. The values for day 6 and day 7 are not shown. Another pattern. Is this the 8? Let's see. 8. This is a plus 8. 8 and 38 is 46. Oh boy. I thought they was going to give you a little extra pattern here in easy pattern thing, man. So this is 70. So this is 78. How many did it complete for the week? So I need to add up all of this. Yeah, boy. Here we go again. Why is my undo button not working? All right, just now. I just need to fix my undo button. Who jinxed my undo button? It just stopped. It happens from time to time. can bring it back up now. All right. So if any mods in the chat, you could remove anybody who's spamming. The people who are spamming need to take a stand up, go outside, and touch grass. That's usually the cure for spamming. Do you know that? Persons who are spamming, it's because it's a long time since they touched grass. The more grass you touch, the less spam you spam. So 8 and 2 is 10, and we have another 10 there. We have 28. Wait. Before I add this, let me make sure that I'm doing the right thing. This is his whole week, every day, push-ups, add 7, add 8s. Yes, we're going good. 10, 10, 8, 28. I did the trick again. 8, put the 2 there. 10, and this is 5, and 5, 10, and another 10, 37. 37. So when you keep adding in 10s, when you keep looking out for the 10s, you make your life much easier. There's always some 10s hiding up there, some 2 numbers that will add to give you 10. So it's very important that you maintain a little touching grass in your life. Sometimes you have to go outside, look at the sky, look at the stars, look at the clouds, and run your feet, your toes through the grass. So that way, when you come on YouTube, you wouldn't feel the urge to just write the same thing over 400 times. Grass. The square root of a number is 13. More than the 13 more. Oof. We have to take the time and read this question. The square root of a number is 13 more than the difference of 26 and 18. What's the difference of 26 and 18? Let's look at that. Difference of 26 and 18, I can do that mentally, is 8. 8 is the number for this worksheet, boy. 8 is the MVP here, boy. Let's just crown 8 one time. How much time we see this number 8 show up in this paper, boy? 8 just in everything, boy. 8, well done, bro. So 13 more than the difference of 8. 13 more means add 13. So the square root of a number is 13 more than the difference of. All you understand what I'm doing here again? Them are kind of backwards working, figuring them out. It's like I'm a maths detective. So first I figured out the difference of 26 and 18. It's 8. And 13 more than the difference of 26 and 18. So I'm going to say 13 more than 8 is 8 and 3 is 11. That's 1, and 21. So why did I do that? 13 and 8 is 21. So the square root of a number is 21. Do I put 21 there? No. Somebody has the answer. I need to find the square of 21. I need to multiply 21 by itself. So if I multiply 21 by itself, so sometimes we do this. Sometimes you see me do this online. Sometimes you see me do this technique. Whichever one you are popular with, you free up yourself. In class, I usually use this. Sometimes online, I use this. I know most schools still use this. 2 by 1 is 40. 2 by 21 is 42. There's a 0 here. I did the 10s first. Sometimes you do the 1s first. 21. We add that up. We get 441. And that is our product. Right there. That's our product right there. Moving on to 41. We're nearing completion, y'all. Holy faith. Holy faith. Write the correct number in each shape below to complete the number sentences. Oh, this one is for you now. We know what to do here now. Tell me what going in the sentence, in the circle. What goes in the green and what goes in the yellow. Careful, eh? This one's slightly different. It's the same thing, but different. Same but different. See if you can figure it out now. We did something similar to this. You notice this one is 67. It's less. It's less. How much less? 2 less. All these tricky things, boy. So much tricks in life. So let's look at this one, because we know we're really good in this part here. So I am devoting all my attention to this line because I could figure this out. I added 25. So this means this is less than 69. It's probably 68. 68 times 25 plus the extra 25. But maths, right? So you do this part first. 68 times 25 plus the extra 25 is 69 times 25. So now all I need to do now is figure out what to put there to make this 68. 1. 1 is the go. 1 is the go. I hope you all understand these questions. If they only bring this question for early in exams, we smoking them. In a library, one of the bookcases has 15 shelves, where each shelf can hold 12 books. So is a shelf in a library 15 shelves? I have never seen a library with 15 shelves in one bookcase. Where this bookcase going up to the ceiling? How much shelf in a bookcase? Go and watch the bookcase in your house. Anyhow, 15 shelves, and each shelf can hold one book. So on each shelf, 12 books. On each shelf you have 12 books. So this is this same kind of question. Oh, there's somebody that needs to get blocked. Let me just see. Oh, poor fella. I think he didn't touch the grass. The grass, I tell her, the grass is the key. That's when you're on the iPad too much. Too much iPad and thing. Sometimes you need to leave the iPad and go and see what the sun is feel like. 12 books and 15 shelves. So the first 8 shelves were completely occupied, where there were 4 books in the 9th shelf. How many books can be placed in the remaining space on the bookshelf? I know what to do. I'm going to say, all right, first 8 shelves, filled shelves. Filled shelves is going to be 8, and there are 12 of them. So 8 12s are how much? That's 96. 8 12s are 96 all day, every day. While the 4 books on the 9th shelf. So the total books would be 100. What a nice number. 96 plus 4 is 100. How many of you all so far so good? There are 100 books on this. And the total spaces, there are 15. Apparently this is the biggest shelf in the world. 15 times 12. So what is 15 times 12? Well, 15 and 30 and 180. 180. 15 times 12 is 180, they are telling me. Okay, I can vibe with that. So how many more books needed? So remaining has the idea of subtraction. So how many more books can we place in the remaining spaces? Remaining, very easy. Remaining, we're going to have 180 minus 100 is 80 books is going to go right there. And then we are going into 43. We are getting near the end. Smell that? That is the ending in preparation for the upcoming, well, look at that. Student Hub Excursion, 12-seater Student Hub Excursion. 18 12-seater buses. Yeah, really reached the end. I'm forgetting how to pronounce the word bus. Were hired to transport the standard 5 students. Mr. Springer then decided to include the standard 4 class. This ever happened in school? Your standard 5 or one grade, grade 4, and then you pick the grade 3. And next grade, get to come on your field trip, boy. They're bringing you 2. Standard 4 and standard 5. How many more buses will he need to hire to transport a combined total of 315 students? This was a whole lot of work just to say not that much. How many more buses will he need to hire to transport a combined total of? So the total is 315 students. And we have 12 times 18 so far. So far, 12 18-seater buses. 18 times 12. Let's multiply it this way instead. So 2 by 18 is 36, and 1806, 216. So far 216. So far 216 spaces. Missing, how many are missing? Missing spaces will be 315 minus 216, which is 99. Which is 99. You can see it, right? It's nearly 100, one less, so it's 99. 99 spaces missing. So how many people in the bus? 12. 12 times what? Once again, we get this 12 with this 99. How do I figure out what's, oh, my handwriting started to get bad. Let me see if I can improve my handwriting. Missing. That's what happens when you reach the second to last question. So 315, we have minus 216, we have 99 persons left to fit. And each bus holds, not 12, each bus holds 18. I was wrong. Each bus holds 18 persons, everybody. So 18 times what gets us close to 99? You all are saying 9? That feels like too much. Let's try 6. 18 times 6. 6 8s are 42 for 102. That's good, because if I use 5, I will get less than 99. So the answer is 6 buses. I think the persons that said 9 were using the 12. I said 12 earlier, I think, so they said 12. All right, 4 digits are shown, using each digit only once. Smallest 4-digit number, that's easy. If I want the smallest number, I'm going to pick all the smallest numbers and put them in front. It's as simple as that. You go in ascending order. So you start with the smallest number. All right, let's see what else they want us to create. Largest 4-digit even number. That's also easy. So to make the largest number, I'll just put 8, 6, 4, 3. This is the largest number. I put the numbers in descending order, but I wanted it to be even. So to make the largest even number, I'll first need to find one of the digits that would make it even. This digit does not make it even. I have to put one of the numbers at the ending that will make it even. Hold on, eh? Yeah, so I need to put one of the numbers that would make it even at the end. So here's the trick, people. Listen to this. We're about to go. Listen to this, everybody. Last trick that will be applicable probably in your exam that is coming. So if you want to make the number even, we need to use 0, 2, 4, 6, 8. One of these at the ending. And I'm seeing 4, 8, 6 get used. So which one do we pick to put at the ending? If you want to make the largest number, you need to pick the smallest one. We need to put the smallest guy at the end, and we don't want to use up our nice, good, big 8 and 6. So let's take the 4 and put that at the ending. Then put 8, 6, 3. The other numbers go in descending order. And that's how we create the largest 4-digit even number. Oh, sorry. Did I say that was the last question? My bad. We have 2 more to go. So 45, when a number was divided by 14, the quotient was 8 more than 56, and the remainder was 9. What was the number? Any one of you all get a lot of problems to understand these questions? Like when you're reading these questions, you're like, what is going on? It's too much words, it's too much operations. If that is happening, I want to advise that you take your time with it, right? So let's see how I would decode it. Let's see what I would say. When a number was divided by 14, so I'm thinking about some number being divided by 14, some number got divided by 14, the quotient. So don't get frightened with this word. This just means the answer. When you divide something, you create a quotient. So like if I said 12 divided by 3 equals 4, 4 is called the quotient. That's the answer when you divide. Right? So the quotient was 8 more than 56. So I divided some number, some mystery number, I divided it by 14, and this number is actually equal to 56? Oh no, it's 8 more than 56. Do you understand how I'm decoding this question? So I have some number, I divided it by 14, and it's 8 more than 56. And the remainder was 9. Oh, there was a remainder, 9. Woo! So there was also a remainder of 9. So I'm dividing by 14 and I get a remainder of 9. What a question. Take 5 seconds and see if you can do the question. All right, I have 5 seconds done. Let me tell you all a secret. Since I started doing this, I have a team of tutors in the student. I'm a team of teachers. They teach SCA level, CAPE level, CSEC level, and I give them guidelines on the question. And most of the questions they pick and make up for themselves and compile based on recent exams, like the last 5 years of exams from all these different examining bodies, especially SEA, NGSA, PEP, CPEA. So what I like to do is not do the question before. So so as you are seeing the question, I am seeing the question. So I like to come in and do the question. It's one of these things that really helps the students to understand. I like to do the question brand new with you. So that way you can see how I decode, how I come up with the idea. Is someone still, is Blame still here? Oh boy, I was trying to give them a chance. Boy. I hope Blame. I hope he's behaving. I think he's behaving now. All right, so here's what you do in this question. You all ready? You all got something? So there was a remainder of 9. I'll come back to this. Remember that there's a remainder of 9. The quotient, the answer when we divide, is 8 more than 56. So what is the quotient? If it's 8 more than 56, what is it? The quotient, I shouldn't write this like this. I should write it like it's 8 more than 56. The quotient is 56 plus 8. So what is the quotient, everybody? The quotient is 8 more than 56. It is 64. So apparently I divided some number and I got 64. Now let's look at a simple division to see what will happen. If I said 10 divided by 5, 10 divided by 5, what is the quotient? The quotient is 2. How can I get back the number 10? Multiply the 5 and the 2. So if I said I'm trying to get back this number and I divided by 14 and got 64, how do I get back that number? Everybody understand what I'm trying to show you there? If I said 12 divided by 4 equals 3, pretend I didn't know that this number was 12. How can I get back the 12? 4 times 3. So if I said some number divided by 14 is 64, how do I get to know the number? I'm going to have to multiply the 14 by the 64. How many of you all think that's a good move? I'm very close to figuring out the number. So the product is equal to 14 times 64. Let's do it like this, 64 times 14. Let's use this style. So I have 4 4s are 16 plus 1. 4 6s are 24. So we have 2 5 6. And then we have 0 6 4. Then we add it up, 6 9 8. 8 9 6. So how many of you all think that that is the answer? Is 8 9 6 the answer? No, we put something in our back pocket. I remember what we put in the back pocket a little while ago in the question. The remainder. It means it was a little more because there was remainder. There's a remainder of actually 9. So what is the number? The number is 896 plus 9 9 and 6, 5. This comes, so everything here will add 1, so I'll get 905. You know, I saw some persons put that answer earlier. Very good. Was that the toughest question that we do today? I think it was. I think it was. So a gardener, so I think some of you all are getting better at this, and some people are not spamming. Again, very good. A gardener is planting rows of flowers, and the number of flowers in each row follows a pattern. What is the pattern rule? Pattern. 7, 12. Is there addition? This is 7. Let's check and see. 5, 5, 5. They keep doing this. They keep doing this. They keep adding 5. They keep adding 8, 5, 12, 11. So it's always adding 5. What does that mean? That means, you tell me what is the pattern rule. I'm seeing Chandani says the pattern rule is add 5 to every row. Not really. When you're giving pattern rules in mathematics or sequences, you need to say the common difference like that, but you also need to say something else. So adding 5 is not a complete answer. 5n plus 2. 5n plus 2 works. Who said that? That is actually a pattern rule for the number of flowers is equal to, now those who do in NGSA, you kind of need to understand this one. 5n plus 2, where, but this is a bit of algebra, where n equal row number. So this is one way to do it. But other than that, you can use a different idea to give the pattern rule. The pattern rule is you keep adding 5. So everybody keeps saying adding 5, the difference is 5. Here's what you will do to get a complete idea. Start with 7. You have to say the first term. So unless you are able to give it in algebra like this, you have to give your first term. Because adding 5 is not a complete definition of this pattern. Adding 5 means what? 0, 5, 10, 15, 20, or anything actually. So you have to say the starting term. Start with 5 and add 5 flowers for each new row. What are the best handwriting in the world now? If there was a contest among YouTubers to the best handwriting, all you voted me number 1. All you know, I'm making that number 1 position there one time. Using the same rule, how many flowers are planted in row number 9? So there's 2 things you can do. We can use this idea, and I explained this idea on an NGSA stream in November. So if you have to go back and find that on my channel, Kerwin Springer, it's one of the last things I did on my channel. I explained how to come up with this. Those of you all in my NGSA classes, I explained that. SCA classes, you don't really need to know this. So NGSA students, you can go back and check it on the November stream. Using the same rule, how many flowers are planted in row number 9? So I can use this rule. I just put 9 here. 5 9s are 40. 5 plus 2, 47. And I'll very quickly get the answer. 47 is the answer. If you don't know that, the other thing to do is just keep going. So we were on row 4 and we got 22. Then we're going to go to 27, then 32, then 37, then 42, then 47. All right. And we will be like 4, 5, 6, 7, 8, 9. On the 9th row, it's going to be 47. So you just keep adding 5. And are we done at the end? This is the last question, people. So when we reach the last question, we had to draw the road because you know why? This one is for the road. This one is for the road. Like the street lights and thing there. And we're in the Caribbean, so we have to be realistic. We have to be realistic about this road. While I'm drawing the road, do the question and don't get distracted, you know. Don't be distracted. if we are realistic about the road, we have to put some grass on the edge of the road. What else is in a Caribbean road? This is the last question, people. It's getting the time to say farewell just now. Of course, if it's in the Caribbean, it must have a little hole in the road and thing. Sorry. Sorry, it's true. There's a pipe on the side of the road. Let's not overdo it in the Caribbean right now. Although I'm from the Caribbean. So we have a little pothole in the road and thing. There's a Caribbean street and maybe the beach in the distance. I don't know. Maybe some mountains. My undo button stop working. My undo button say that's enough drawing. For which row will 62 flowers be planted? Well, so those of you all who know the technique with the 5n plus 2, 5n plus 2 equals 62. So 5n is equal to 62 minus 2 is 60. 5n is equal to 60. N is equal to 60 divided by 5. It's going to be 12. So the 12th row. Now, if you don't know that technique, which I said is not applicable for for SEA, what you would do is just keep going. So for which row will 62 flowers be planted? There's another thing you can do. We started with how many flowers? 7 flowers. So we had 62 and we started with 7 flowers. So think about that. So if we started with row 1 at 7 flowers, I can say 62 minus 7 is 55. Are you all okay? And remember, each time I keep adding 5. How many times did I add 5 if I add 55? How many times did I add 5 if I am on 55? I have 55 set added after the 7. You all understanding how I'm going to work this out quickly now? Nice little technique here. I started with 7 flowers. I removed that 7 from the 62. I have 55. This means I added 5 how many times? Added 5 11 times. So is it row 11? No. It's not row 11 because the first row started with 7. And this is the first row here. I remember I removed the first row. So it means I am on 1 plus 11. And that's another way to figure out the 12th. So the last way to figure it out is to just keep going down with your table, which is what most students might do. 10, and you keep going 11, 12, until you reach the number that's required. That's the longest method, but it's also foolproof. It's not 13, it is 12, which the 62nd flower would be planted on row 12. All right, and just like that, we are finished with the first session. A lot of you all will be watching this after the live stream. If you're watching after the live stream, congratulations, you still watched it. It's 2 hours. It's a 2-hour long stream. Next week will be a little shorter. Maybe not, because there'll be less questions, but it's a tougher topic. We're going to be doing some tough topics coming down in the weeks. We started with a nice, easy thing here, computation, numeration. That's a lot of addition, multiplication, subtraction, patterns, place value, numerations, ascending, descending order, all of these different things that we did. Congratulations if you made it here in the very first few minutes and you were here until the ending. We had 1,100 people here. That's a record for this primary school level. Sometimes at the CSEC level, we're able to have like 4,000, 5,000 students. That's at my channel and the Cohen Springer channel. Make sure you are subscribed, press like. See you next week at 1 p.m. And now we are going to do all the thing that we normally do. We are going to shout out maybe about 20 persons. Let's go. Thai Asia, you can feel free to shout out your school, your lessons teacher, your school teacher, your country, your anything, your dog, Shariza, Sophia, Afisha, Akeem, Addison, congratulations on making it. Arima Gills, I'm seeing Janelle, I am seeing Ravindra. I am seeing Keely, Healy, Amma, Malia, Malabar, RC, Melinda. Anastasia has my book. Congratulations. MG, Michael Jackson. Is that you? Pink. Hey, Pink, you behaving yourself. I hear people talk more Pink just now. Pink, I hope you're behaving. Kyla going and touch some grass here. Giselle, Janae, Ari McGill, Lihula, Ari McGill's here. What? Tariq, shout out, SFSD, Celine, Callista, Finba, Christy. So just a couple more. We'll do more of this. Montrose government always inside. Big up the whole of Montrose government. We need less questions. We need more questions. This is preparing you for the exam, so we have to give you all good preparations. Big up to the whole of Guyana. I saw somebody shout out that. Ethan, yes, you. One person wants to go to Vishnu Boys. I saw that. Belmore Gills in thing. I'm seeing somebody with my surname there, so I do maths paper alone. Yes, maths paper alone. Robert, Village Hindu School, Felicity. And just like that, we are at the end of our first session, ladies and gents, boys and girls. Love and blessings. Press subscribe if you haven't yet subscribed to the channel. Your parents can follow me on Facebook if they want to be updated on what's happening. Those of you all in the class, I will send the worksheet for tomorrow's, for Sunday. Tomorrow, please go out on Monday. So you'll get a little time to do it. And till we meet again.